Welcome to the FAS International Conference on Agrarian Change. Please note a few housekeeping announcements. This session that you are about to attend will run from 2:25 p.m. to 4 p.m. And after this session, we will have a short tea break at 4 p.m. On behalf of the organizing committee of the International Conference on Agrarian Change, I'm pleased to present the chair, T.N. Prakash Kammardi.
Sincere apology for the delay. I had some confusion regarding the both venue and the place. Good afternoon. Welcome to you all. You are here in one of the parallel sessions to address the larger theme of this international workshop. How to bring, in my own understanding, normally you will have the subtitle for each session also. This session, without subtitle, hopefully, in my understanding, each session is supposed to do justice to what are the larger aims, objectives of this workshop. Dr. Ramchandran has made it very clear in the very beginning itself, what are the agrarian issues. The one, which is very important for us, from the agricultural scientist and technology point of view, how best, we have to make use of the agriculture science and technology to address the emerging challenges, in my opinion. With the kind permission of my co-panelist, let me make. Normally, I am supposed to make, and the chairman is supposed to make his or her remark at the end, Since it is a little open-ended, I am also a bit new to the other panelist. Hopefully, in this direction, if whole session moves, I think we can make overall justice to the overall objectives of the workshop. Well, friends, I am coming from Karnataka. I am coming from Bangalore. I am coming from a place very near to the international airport called the Bangalore International Airport. I think you might have read in the newspaper that area called the Devanahalli Taluk, where the international, one of the best international airport in India, in Asia, someone said it's in the entire world. In and around that the international airport belongs to a taluk called the Devanahalli. It is called the Devanahalli, where the Tipu Sultan was born there. It was in the limelight for quite a long time. I don't know how many of you observed. Mr. Yashwant is here. He happens to head the Karnataka Pranta Rait Sangha. That is a CPM wing of the farmers unit in Karnataka. That villagers, 13 villagers in and around Bangalore, were on agitative path for not 1 day, not 2 days, almost 3 years. What for? They were against to forceful acquisition of the land. This is the third phase of acquisition. 13 village people were against to the acquisition of the land. 3 years historic struggle, Morning, someone has mentioned about the historic struggle of the 2019 against the 3 farm laws. Ultimately ended up with a positive note of withdrawing. Same thing happened here also. Somehow government has to bulge. First time in the history, government has to withdraw the order of acquisition. It is not an end. In Karnataka, where among the other progressive state, which has brought the progressive land reforms to give the tillers to the ownership to the actual tiller, now we are in the process. Farmers are in the fear of losing the land, what they have got in the 1974 land reforms acquisition. Land acquisition is a policy term. Anywhere in the 6-7 places, most are in and around Bangalore only. They are against. We are not ready to give our land. Land acquisition is a sophisticated term. They say, namminda bhoomiyannu kittukoladu anta, forcible snatching away our land. Well, friend, I think I am mentioning in the beginning itself, since yesterday I have been watching this land acquisition in the policy term, forcible snatching away the lands of the farmer going on in the different parts of India is totally missing. I think, in my opinion, the land acquisition should be a contemporary agrarian issue. So how we can integrate to the present today's parallel session, science and technology? What is the underlying cause? In and around, the value of the 1 acre of land not less than 10 crore rupees. Average land value in Karnataka is 25 to 35 lakh rupees. 10 crore rupees, I am an agriculture scientist. You cannot grow anything beyond 10 quintals of ragi or 15 quintals of maize. Okay, it won't give you not more than 10 to 15,000 rupees, whereas the land value is 10 crore rupees. Thanks to policies of globalization, liberalization, I am very careful in using the term neoliberal policy to thank them. Is it wrong per se? Your asset value has gone up to the 10 crore rupees. In Karnataka or anywhere in India for that matter, each farmer is rich by asset. If you ask the asset value of the farmers in Karnataka, I said, 25 lakh rupees. Poor by income. So there is what is called as the financial parlance, asset turn. Okay. So how to address this one, make asset to turnover ratio. So you have the huge land value. So on one hand, and you cannot get it anything reasonably good from back, and you have the force to snatch away that land. So this is something in a very contemporary issue. How to make land productive is something which is very, very important for us. So here is the case, we are supposed to come that one. We have to make best use of science and technology, not only to produce food and also feeding the world and saving the world should be I think, our forthcoming aim of the both agriculture scientists and technologists. What you meant by feeding we have to produce. But agriculture has fast emerged not only as a food production sector, it is also saving the globe against the climate change. By definition, agriculture is a carbon sequestrator. Any photosynthesis, any green thing, it sequesters the plant carbon. With that, it reduces the carbon content. So why I am raising this one, one or two lecture, always, if you get into the agriculture is the greatest polluter. I think 13% of the global green gas coming from agriculture, number one. Putting the blame on agriculture. True. The rain-fed paddy, the irrigated paddy, livestock, all pesticide use, excessive use of agrochemical adds to the global warming, no doubt. And second thing, we look at how to save the agriculture from the climate change catastrophes. The third important, for me, what is important, I think I sincerely request the scientists who are making the presentation, look at agriculture from the carbon sequester point of view, carbon farming. Agriculture is a carbon sink. At the international and national level, it is taken care very well. I think with that, we can make agriculture not only as something which is supposed to feed the world and also save the globe. With this, keeping in mind. So with that only, I can say the challenge for us, not only make agriculture land remain in agriculture, farming, but also agriculture land should remain in food production. So to address the challenge, to save that the limited land across the globe, only 10% of the land, I think, is capable of producing and feed us. We have to save that one. Keeping this one in mind, let us hope we are supposed to, let us see that how best we can address this issue also. In addition, I don't want to preempt what the most learned speaker are going to make presentation. Keep this is also in mind. So with this, how best we can make use of science and technology. See that farmers keep their land for food production. See that farmers also keep their land with all possible additional remuneration, additional support, additional satisfaction from the land use. Thanks a lot. Sorry for taking. I have got the remainder. Sorry, I know very well. I don't speak at the end. Pardon? Shall I call the speaker? I think she had made some announcement. I think you please, madam, you please see that who is supposed to present right now.
Our first speaker for this session is K.K. Narayanan.
Hello. So I'm all wired up so I can be a little more intimate with all of you right here. Is it okay? Okay, good. Good afternoon, friends. Thank you, Mr. Chairman, for inviting me. Nice to know that you are also from Bangalore. We are both there, and both of us are agriculture scientists. Good. So what's ringing in my mind now is the statement made by the last speaker of the morning session. If I remember the name correctly, it's Mr. Mohan Guru. Gopal Guru. Gopal Guru. Okay, Gopal Guru. Thank you. And thank you. Is it on? I thought he was talking about inequalities. And what struck me was when he said that science creates inequalities. I would like to look at it a little differently. Science is agnostic. The development of science is agnostic. The purveyors of science, their persuasions, the ultimate intent with which the scientific technologies are deployed is what can create inequalities. And we need to be guarded there in the sense that with proper regulations, make sure that the fruits of science are fairly distributed among all the stakeholders. And that's our responsibility. So let's talk about science and how science can help address some of the major problems for agriculture that agriculture is facing, with a special reference to the context of Kerala, because I also grew up in this town of Trivandrum and I studied here. So I have been closely watching, even though I am now away in Bangalore, I keep looking at things, what's happening here. So with those, let me get on with my slides. So the title that I have put is Harnessing Technology for Sustainable Agriculture. When I talk about sustainability, we are talking about 360-degree sustainability, including financial sustainability. That's very important. And Kerala's path to food security and climate resilience, I have ventured into giving some suggestions which needs to be debated and fine-tuned for the state to actually make sure that agriculture in the state gets out of some of the morass conditions that it is already in. We know the challenges that agriculture has been facing from the very advent of agriculture. You know, people say it started about 12,000 years ago, in the Neolithic age. But I have reasons to believe that particularly in some geographies, like central India and other places, I'm not getting into that, that agriculture started or settled farming started at least 20 to 25 millennia before what many other people assume when agriculture has begun. So even from that time, one of the major tasks of agriculture was to meet the demand for food and other products which people use. And this cartoon essentially suggests that the demand is increasing because there are more and more mouths to feed, and the demand has to be met against depleting primary resources of production. But I want to look at it in a different perspective. Let's see how fast the demand is increasing or how fast the mouths are increasing. It took about 2,000 years from the time of Christ for the global population to reach about 2.5 billion people in this world. The next 2.5 billion was added in about 50 years. You can see the time frame. And today the world population is about 8 billion people, out of which 1.4 billion is in our country. It has taken less than 25 years. So it's accelerating, it is going at a geographic pace. Today we produce enough food for all the people, but we still have problems of providing access to that food. And that's where the discussions on equity and other things should be focused on rather than looking at science itself. Now, Kerala has done pretty well in terms of its population. You know, today, if you look at the population, it has stabilized somewhere around between 3.5 crores to 4 crores, or 30 million, 35 million to 40 million. And the replacement, we are not growing faster. Compared to all the other states, I think our population growth rate is near or slightly less than the replacement rate, which is around 2.2 or something. So it is around 2. But then there are still, we are not out of the woods yet, particularly in Kerala, because the density of population, the land mass is small. It's a coastal region and then hilly region, Western Ghats. In between you have the Midlands. So the density of population is quite high, which means there are competing needs. There are competing needs for the same resources that go into primary production. And these need to be addressed. And I believe science can play a major role in addressing some of these issues. Now, when we talk about sustainability, I told about financial sustainability also. So, financial sustainability is a problem in terms of agricultural practitioners, particularly our farmers. Now, this slide, even though it looks a bit complicated, illustrates that, but let me try to make it simple and explain some of these issues. See, India is here. What is there in the x-axis is the average per capita GDP of a citizen of this country. That is the total GDP divided by the number of population, 1.4 billion or whatever is what is there in the. So in India, the average GDP is around 10,000 US dollars. Or in other words, if you reduce it to monthly income, an average farm family earns about between 12 and 15,000 rupees per year, depending on which estimates you rely on. But look at, this is the value add or the per capita GDP of a farmer or somebody involved in primary production. And there, it actually maps around 200 US dollars, which means somebody engaged in agriculture is at least 4 times less productive compared to an average citizen engaged in other professions. That situation has to change. But we have you will remember that we have over almost 45 to 50% of all working people engaged in agriculture. And this is reflected in the contribution of the primary agriculture sector to the GDP, which is only about 13%. So that situation has, and technology can. I want to persuade you to believe that technology can help change some of these dire situations. If you move on to the next slide, there are more challenges. There are plenty of suggestions. I can give a litany of things and take the whole hour of my talk, or the whole 20 minutes of my talk just talking about challenges, but I limit it to what is the elephant in the room today, which is actually the climate change. We all know that in the last 100 years or so, the temperature, average temperature, global temperature has increased by 1 to 1.5%. And this is highly correlated with the amount of greenhouse gases which is being produced anthropogenically. Human activities produced greenhouse gases, which is sometimes expressed in equivalents of carbon dioxide, is increasing. 100 years ago, the average atmospheric carbon dioxide concentration was about 200 to 250 ppm. Today it is about 400 to 450 ppm, and there is enough evidence to suggest that some of these greenhouse gases can lead to global warming. Added to that is the depletion of primary resources, water, land. This is a picture which shows that many regions of northwestern India are already drawing more water from the soil compared to what is actually going back. That's a red region. And what's the result? When we talk about borewell-based irrigation systems, the water levels, they have to dig deeper and deeper wells. And that is already showing up, reddish patches in other parts of the country as well. Science can address these solutions. Deliberate science or serendipitous science can address these solutions. When we talk about agriculture or farming, it all started with the domestications of certain groups of plants and animals, right? So when we talk about domestication, there are 2 aspects of the organisms which has been modified and continues to be modified even today to make it adaptable to farming. What are those 2 aspects? One is the nature of the organism. When we talk about a nature organism, you talk about the physical attributes, the emotional attributes. I'm 5 feet 10 inches tall, that's my nature. And I keep jumping around from the stage, that's also my nature. So the nature of an organism is actually controlled by the genetic makeup, or the potential of the nature is controlled by the genetic makeup. So ever since the advent of agriculture, humans have been deliberately or subconsciously modifying the genetic makeup of the domesticated plants and animals. The second aspect which needs, can I have some water please? No, I'll take this, thanks. Thank you, Sandipan. The second aspect is nurture. Are you providing the right ambience for these plants or animals to perform the way you want to perform? It may have the genetic potential. I had the potential to become 7 feet, but because I didn't get enough food in my childhood, I stuck at 5 feet 10. That's the issue of nurture. So it's modification of the nature and nurture which actually determines the domestication of plants and animals, making them suitable for farming. See, I want to illustrate it with one example. Talking about nurture, we talk about fertilization, right? We talk about, fertilizer, use of urea, use of gobar, use of farmyard manure and stuff like that. So when plants grow, when they put on the biomass, where does the nutrient come from? It has to take it from the soil. Carbon comes from carbon dioxide. It is fixed. He mentioned about photosynthesis and carbon credit and carbon neutrality and stuff like that. It is fixed through photosynthesis. Now, when we do cultivate plants, we take away portions of that biomass away as our grains for food. You had lunch today. Somebody had produced it in a field. From that field, that biomass has come into our tables now. So, which means when you do agriculture, the field is getting mined of some of these nutrients. So there will be depletion of nutrients. It's nothing unusual. Unless it's a forest where the plants die, they fall there itself, microorganisms act on it, decompose, the nutrients are cycled back into the soil or to the other parts or other plants, fungus, all saprophytes and stuff like that. So you have to add nutrients. From the very beginning, people realize that you have to add if you do agriculture. But today, the world is supporting about 8 billion people. And to produce the food for that, you have to supplement it in many different ways. One of the ways is by adding synthetic nitrogenous fertilizers. You talk about urea. Urea, even though it is synthetic, it is no different from the urea that we produce in our system. Urea was first discovered from human urine. You must remember that. That's why it's called urea in the 1780s. Yes, by a scientist who also discovered oxygen, Priestley. So that urea now, only in the early 20th century, 1908 or something, two scientists, German scientists, Haber and Bosch, they discovered the Haber-Bosch process through which you can produce ammonia, fix atmospheric nitrogen. Otherwise, only plants had the capabilities. And of course, some microbes had the capabilities to fix. That is not sufficient. So, what I am trying to show here in this picture is the nitrogen map of the world. There are regions where the soils are deficient in nitrogen. But I want to draw your attention to this particular statement. Nearly half the population in this planet wouldn't be alive if not for the abundant food made possible by nitrogenous fertilizers. This is significant. So when we talk about we don't need synthetic nitrogenous fertilizers, that's not the way to look at it. We will see how we can reduce its use, how we can balance it as bio-fertilizers and bio-nitrogenic sources, so that it also encourages microbial activity. So out of these 8 billion people, who are the ones who wants to choose not to be around? That's a question. It's an ethical question. Good. So he's already shown me 5 minutes, so I have to proceed very fast. So talking about changing nature, initially there was selection. The ladies would go out of their caves, when the advent of agriculture, when humans were shifting from hunter-gatherer to settled agriculture, they would take the most plum seeds and sow it again, do the selections, and they were inadvertently improving the genetic makeup of the plants. Now we have more sophisticated techniques. We leverage the natural organism called Agrobacterium tumefaciens, which is a natural genetic engineer. The sweet potato that we eat is highly genetically engineered. You must have seen some of the references because we have got techniques today to analyze. But you can do, so what happens is we have essentially broken the reproductive isolation barrier. So you can take genes from one organism and put it into another organism and get it to express. As long as it's done ethically, it can actually solve many of the problems. So BT cotton is a typical example, and you ask any farmer which field he prefers, and he will point it out without any doubt. But you must see that, technology from after the advent of BT cotton, from about 140 million bales, 14 lakh bales, the peak yield peaked at about 40 million bales or 400 lakh bales. And thereafter there's been a plateau. So I just want to make this point, the technology development is dynamic. Technology development is not a one-time affair. See, you had, whether it be the discovery of fire, making fire, whether it is be cell phones, technology constantly has to evolve to make sure that it meets the needs of the day. And when there is a choking of that pipeline, you will have sometimes technology sitting on the shelf, ironically not being used for the advantages that it can confer. And today there are technologies by which you can actually look at complex modifications. C3 to C4 plant. Some of you physiologists sitting here may understand what is a C3 versus what is a C4 plant. Instead of putting one gene or other things like in BT cotton, technology has moved on. You can manipulate entire biochemical cycles. And those of you who are interested can check with me later outside of this meeting so that we can discuss some of these issues. Gene editing. You look at any of the major papers, everybody keeps talking about gene editing, where you don't introduce a new gene, but make small changes which either knocks out the function or modifies the function and allows you to get the benefit of technology. In fact, many of the problems that arise due to climate change, particularly abiotic stresses, are more amenable to addressing by techniques such as gene editing compared to some of the earlier. So they were all hitherto thought to be intractable. That's not the issue. Of course, many countries have now allowed gene editing to be considered as normal plant breeding. India is one of them. Now we can talk about efficient nitrogen use. Sir, you mentioned in your opening about carbon neutrality and how do we have to think about nitrogen production using the Haber-Bosch process is a highly energy intensive, so carbon polluting kind of operation. If we can substitute part of that using biological nitrogen, which can be fixed, there's a huge advantage in terms of addressing issues of climate change. Let us look at Kerala. Some of these new technologies have great potential to address specific problems to, you know what the crop this is, right? This is pepper. The Romans 2000 years ago, they used to come here. Okay, sir, I think you are very strict. Thank you. And see, I started my career in SADU, Special Agriculture Development Unit in Department of Agriculture, looking at pepper rehabilitation. So I know this, plantations like this, 4, 5, 6-year-old plantations in 1 week, they will all be down because of Phytophthora capsicum cost. So can you address this using RNAi technology or the gene editing technologies? We need to explore those possibilities. When you talk about urbanization is increasing, in fact, Kerala, I would say, is no rural area is there. It's a continuum of urban centers. So some of these precision farming technologies will have a major role in addressing mechanization. No, generally we have been against mechanization. I agree. A machine like this doesn't make sense in most of the geographies of India. This is Brazil or USA where you have farms which are like 2,000 hectares, 3,000 hectares. We need to have modification. This is something made in Namakkal. You see a tractor sitting, I am sure you must have seen some of these combine harvesters. So your mechanization should be affordable, and more importantly and very importantly for all the economists here, it should be scale neutral. So whether you have a 1-acre farm or a 100-acre farm, proportionate benefit should come. Any technology is delivered to the seed is largely scale neutral. So we can discuss that outside of this particular presentation. You need to make sure the incomes are increased, so secondary agriculture or value addition becomes very important. Okay, so both the government and civil society have a role in promoting responsible science to address serious problems in agriculture. I'm not getting into that. So there are several policy issues which I have discussed in the paper that I have submitted, and I'm sure you will all have access to those papers, so I'm not going into that. In fact, what is one or two points Kerala is a plantation economy. In fact, the Kerala farmers are slightly better off in their income levels compared to rest of the country. We said, 2000 Kerala farmers make a little more, but not enough still. Still there is a differential between average GDP and the farmer GDP. So we should leverage the plantation economy because largely we have coffee, tea, pepper, and cashew, coconut, and many other crops. I think we should promote appropriate mechanization. I think these adjectives are very, very important. In fact, Dr. Ram, Mr. Ram in the inaugural speech, N. Ram, I mean, because there are so many Rams around, sorry. N. Ram said that agrarian, he described the meanings from different dictionaries or different. So I am using it as an adjective when I say science and technology will actually improve the agrarian economy of this country. And that's very, very important. So finally, last slide, sir, and the last take. Let me circle back to where I started. Science, in its practice, is where the persuasions and the inequalities and other things actually come. Science per se is actually agnostic. We should all, I hope I have persuaded you to suggest, or I will continue to do that, to suggest that we should promote responsible science, particularly in the field of agriculture, farming, and food. It's very important. And we should have regulations, strong regulations, which make sure that the science or the fruits of science in the form of various technologies actually help all these stakeholders in an equitable way. It should prevent somebody profiteering, somebody drawing excessive benefits out of it at the expense of some other stakeholders. And that's up to us. So I am talking about we should have proper, strong regulations. Did you hear me right? We should have strong regulations. So strong regulations, I like to compare it with the strong brake system of an automobile. Yes, you heard me right. Strong brake system of an automobile. A brake system in an automobile is not just used to stop the car, but it is, in my view, it helps the car move faster and faster and faster. Think about it. Thank you. Sorry, sir, I took a few extra minutes. Will I take it here?
Discussion.
Recording in
Now we
progress.
have Sreeja Jaiswal presenting.
So in this presentation, I like to begin backwards. I first tell you what the main finding is, and then I explain how does these main findings come about. So what the main finding is that none of the scenarios that limit temperature rise to 1.5 degrees Celsius or 2 degrees Celsius in the IPCC scenario database meet the goal of zero hunger in 2030. And none of them, except just one scenario, projects world with zero hunger even in 2050 or 2100. The average number of people at risk of hunger in 2050 in C1, that is 1.5 degree scenarios, are around 459 million, and most of them residing in South Asia, Sub-Saharan Africa, and rest of Asia. And similarly, in 2100, the situation improves only slightly, with around 300 million at risk of hunger. And there's, as I mentioned, just one pathway which projects zero hunger in 2050. It's called the Sustainable Development Pathway, or IMP-SP in the IPCC. I'll discuss this in more detail towards the end of my presentation. So what causes this rise in population at risk of hunger in these projections? There are two mechanisms. Basically, a main channel through which this happens is uniform global pricing across all sectors and regions. So these models apply a uniform global pricing across all sectors and regions. What this means is whatever the sector, transport or agriculture, whether in the EU or in India, the emissions from carbon are priced similarly everywhere. Yeah. So what this leads to two things. One is it leads to diversion of land from food crop towards energy crops and afforestation and reforestation because of the opportunity cost here. And this leads to competition for land used for food production and livestock. The other channel is that there are costs associated with reducing non-CO2 emissions, so methane and nitrous dioxide emissions from agriculture and livestock. And then because in certain activities like livestock, there will be residual emissions because it is intrinsic to the activity for enteric fermentation of in livestock, for example. So there will be costs associated with this residual non-CO2 emissions. And both these mechanisms together, they lead to increase in food production cost, ultimately leading to increase in food commodity prices and giving rise to people at risk of hunger. So if you look at the various variables which affect this, so firstly, looking at afforestation and reforestation. So the model scenarios project massive increases in land brought under afforestation and reforestation, mainly in Sub-Saharan Africa and Latin America and China, to achieve the 1.5 degree or 2 degree Celsius goals. So here you can see in the blue bar, which represents 2030 outcomes, then the red one 2050 and the green one 2100 outcomes. So in million hectares you see that the land devoted to afforestation and reforestation is rising substantially in Latin America and in Sub-Saharan Africa as well as China. And in C2 scenarios, which is scenarios with overshoot, that is temperatures will exceed 1.5 before coming back down. So you see that towards the end of the century, there is much more higher increase in land brought under afforestation and reforestation, meaning that the temperatures would be brought back to 1.5 degrees Celsius by removing carbon dioxide from the atmosphere by afforestation and reforestation. And similarly, for energy crops, you see a similar pattern, and the difference between C1 and C2 being towards the end of the 21st century, you have much more land being devoted to energy crops to bring back temperature within the 1.5 degrees Celsius rise. So, in effect, what these overshoot pathways are doing is not only shifting the burden of land-based mitigation onto future generations, but to specifically future generations in developing countries. And if you see non-CO2 emissions, so the percentage of, in percentage terms, the amount of reduction expected from developing regions in Latin America, rest of Asia and China is much higher than what is expected of a developed region like North America. And also the EU shows a comparatively lower decline in percentage terms for methane emissions from agriculture. So ultimately what it does, it leads to increase in food prices of food crops and livestock. And the increase in food prices, which would be which Sub-Saharan Africa and South Asia will face, is going to be much more than what EU or North America faces. So if you see in the C1 scenario here, the prices are rising much more for Sub-Saharan Africa than they do for say North America or here in Europe. EU, this is EU actually, yeah. And you see similar trends across the other scenario categories as well. And then food demand from livestock products, which is an important subset of food demand.
Sorry, Sreeja ji, you have 1 minute time to, sorry for the time constraint, you have 1 minute time to summarize.
All right. Okay. Then the food demand from livestock products also, you see the food demand is unequally distributed. So the global north maintains much higher food demand from livestock products than the global south. And as a consequence, you have much greater population at the risk of hunger. So why do the IIMs project such unequal outcomes? This is because of these are cost optimizing pathways. They do not take into account any equity concerns or any socio-cultural feasibility assumptions. And this kind of pathways and assumptions are pervasive throughout IPCC pathways. So it not only affects food security, it also affects how energy inequalities, income and consumption is distributed between the global north and global south. And very quickly, if I can take just one more minute, I wanted to talk about the scenario which limits temperature rise to 1.5 degrees Celsius and meets food security goals. So there is just one scenario, like I mentioned, which leads to leads to zero hunger in 2050 and 2100. And how this scenario does it is by it assumes that the entire world is going to move to eat lancet diet. But this is and so this solves two major dilemmas. So it reduces the land competition between food and afforestation and energy crops, and it cuts non-CO2 emissions automatically. But the outcomes are still very unequitable. So what you see is that Europe continues to maintain at least twice as much food consumption from livestock products than sub-Saharan Africa, where it is already very low. And there are also several challenges of implementing an eat lancet diet. So just to give a conclusion that global south diets, even in such a scenario which meets zero hunger, becomes disproportionately plant-based, reflecting unequal transition burdens. And there are, of course, many more challenges with implementing Eat Lancet diets, and a lot of scholars and analysis has pointed out that it does not perform very well in meeting global micronutrient deficiencies. It is also does not take into account the employment concerns related with cutting down on livestock in developing countries. It also takes a one-size-fits-all approach without local stakeholder consultation, and it is also unaffordable for the world's poor. Uh, and there are other concerns also with how the model reaches eradication of poverty. And basically, what the model does, the scenario does, it eradicates poverty through international transfers, international aid, and by relying on redistribution of national carbon revenues, and not on any dynamic socio-economic changes in developing countries. And this is a very concerning assumption because the kind of international transfers they envisage for poverty eradications is several times what the current overseas development finance is. Okay, and it is also highly questionable whether, if you communicate clearly these kind of assumptions to policymakers, whether this would be acceptable to policymakers in the global south. So to conclude, of course, there's need for more operationalizing equity and common but differentiated responsibilities, but there's also a very essential need for transparent communication of these scenarios. I think I'll conclude my presentation there. Thank you.
The next presentation is by Niveta Jain. She's going to make presentation online on greenhouse. Okay, she's already there. Yeah. Now, is it Niveta Jain? So she's going to make presentation on greenhouse gases emission from agriculture, a critical perspective. Madam, you can take 20 minutes time. Your time starts now.
Okay, okay. So, can I share my presentation?
Yes, ma'am, you can.
Can you see my screen? Can you see my screen,
Yes,
please?
we can.
Yeah, there is a slight change in the title. I'll be I slightly modified it. So I'm Dr. Niveta Jain, working as Principal Scientist with Division of Environment Science at Indian Agriculture Research Institute, New Delhi. I'll be covering in my talk about how much is the contribution of agriculture, how it is changing globally and in India, what are the mitigation options, what are the barriers and mitigation options, and what are the way forward. So, as we all know that everybody is talking about climate change. So, what is climate change? As per the people's perception, the temperatures are increasing, the extreme events are increasing, and according to IPCC AR6 report, you can see that in this graph, it is plotted from around 1850 to 2020, and you can see how the temperatures are being changing. The rate of change of temperature, if you see here, the temperature change was around 0.23 degree, but when we go beyond 1961 to 90, it is 0.36, then 0.58, and accordingly, we see in the current scenario, it is 1.26. So if you see the change of rate of last 50 years, it is 0.128 degree, but in 100 years, it is 0.74. And if you go for, this is all decadal change. So this is how temperature is changing and which is causing the climate change. Now, what is contributing? There are major greenhouse gases which are contributing to this climate change. And if we see the contribution of different gas wise, we see that carbon dioxide contributes approximately 75%, methane 16%, nitrous oxide it ranges from 4 to 5%, and fluorinated gases are 2%. Now, when we compile the inventory at UNFCCC level, where around 198 countries are signatory, the inventories are compiled in the form of economic sectors, and the major sectors are your energy sector, which includes the transport as well as energy, and then industrial product use, which is your industry sector, and then agriculture sector and waste sector. Now, global greenhouse gas, if we see by sectoral wise, electricity production, energy, and transportation are the major contributors, followed by agriculture sector, and then industry, building, followed by very minor from the waste sector. Now, if we see the trend of greenhouse gas emissions, which are going from one year to another year, this graph shows from 1919 to 2019. And GHG emission, if we see from the growth rate, here this graph shows the growth rate. From 2000 to 2010, the growth rate is very high. This is plus 2.1%, and after that, there is some reduction. And you can see in the list here, I've tabulated that how the emissions are increasing by percentage compared to 1990. Now, why 1990? Because this is the base year where UNFCCC, according to Kyoto Protocol and Paris Agreement, has agreed that from this, we have to compile the inventories and see some countries are considering the mitigation or reduction based on 1990 as a base year, and some countries 2005. So, sorry. I think there is some. So if we see the temperature increase, if we don't go by additional mitigation, then this legend shows that how the changes will, the temperature increase will provide additional risk due to climate change. So if we have a threatened system, you can see here that if we don't apply any additional mitigation, then global mean surface temperature is projected to increase in the range of 3.7 to 4.8 degrees based on the projections by different climatic model by 21st century. And majority of this falls under the very high to high risk. So we have to take action at present. Now, global GHG emission trends, if we see, here this graph shows the agriculture and land use as well as crops and livestock sector, because in agriculture sector, livestock is the major contributor. Livestock sector contributes immensely to the agricultural emission, to the global total emissions. And here you can see there is a fluctuation in land use, but the crop and livestock sector is continuously rising. However, when we see the ratio to the total emission, that is decreasing. Now, if we see the contribution of different countries, India stands at the 4th position, China being the first, USA followed by USA, and then European Union to the total greenhouse gas emissions. But when we see the agricultural emissions, then India is on the 5th position. This is the data for 2016, because several countries have not submitted the 2019 inventories. Now, slowly they are submitting. So I'll be compiling those. Now, when we go deep into the agriculture sector emissions, here you can see that yellow bar shows the soil-based emission. The soil-based emission are highest from USA, followed by China, Europe, and Brazil. India is very less compared to other countries. But when we talk about enteric fermentation, India stands second after Brazil because of the livestock population. And rice cultivation, when we say, China stands first, followed by India. So this is the overall situation of global GHG emissions as well as the agriculture sector emissions. Now, sectoral emission, if I talk about India's 2020 emissions, India has submitted its biennial update report last year only, not last year, this year in August only. And during this period, India has emitted 2.96 billion tons of CO2 equivalent without land use land cover change, which is approximately 5% of the global GHG. And with land use land cover change, it is 2.44 billion tons. That means this much, around 0.5 billion tons we are sequestering. However, India's agriculture is only 1% of the global GHG. So, though India is being blamed, but ours are not luxury emissions. We are having the survival emissions. Now we see sector-wise contribution. So here also, again, energy sector is the major contributor, followed by agriculture, then industrial sector, and then waste sector. Now, if we see the gas-wise contribution, here 80% comes from carbon dioxide, followed by methane, and then nitrous oxide. Now, if we see the overall trend from 1994, because India started giving the inventory from the year 1994 until 2020 we have submitted. So if you see, this energy sector is increasing, and that is aligning with our urban industrialization and urbanization as well as our growth. So our emissions are increasing, but you can see in 2020 the emissions were reduced, and to some extent it was due to COVID also, and mainly transport emissions were reduced. Industry sector also slight decrease is there, but there was no change in the agriculture sector because agriculture sector did not stop even in the COVID also. And if we see the rate of change, so you can see in this graph that energy and agriculture, there was not much decline, but if you can see the total with and without LULUCF was decreasing, and that was due to energy sector mainly, which decreased, and industry sector. You can see these two graphs shows in energy as well as industry. And very soon India will be submitting its biennial transparency report. So if we see especially the agriculture sector, now let us come to agriculture sector, which represent 13.7% of the total emission, and the total agriculture sector emission was 406 million tons of CO2 equivalent, with methane as a major contributor and nitrous oxide as the second contributor. And you can see 55% comes from the livestock, followed by your agricultural soils, which is direct emissions. Then we have indirect emissions, and then this others include your indirect emissions from the soil, manure management, and field burning of the crop residue. If we see the trend from 1970 to 2016, sorry, this is 2016, nitrous oxide is the second largest contributor in our country. So if we want to have a better future, how do we go about? Now, at global level, if we have to save future below 1.5 degree, which is about to cross 1.5 degree now, what should be the carbon free future? If you see in this graph, every sector has potential to reduce. So we at the world require to reduce around 30 gigatons of carbon emissions by 2030 so that we can maintain a temperature of 1.5 degrees. And there are multiple options suggested that how can we go about. These are based on certain experiments, certain publications, and some theoretical assumptions. If we talk about agriculture sector, 6.7 gigatons reduction is required. Food system and others. Others include so many things like it is a total of through supply chain. So livestock is there, then supply chain is there, then land use is there, and then we have crop production system. So overall, we have to reduce around 6.7 gigatons of emissions. Now, large fraction of our emissions come from the food wastage. Like you people are there in the conference also, I would request that measure how much food is being wasted and how much is being consumed. On an average, at global level, food loss and waste. This includes losses at the production level, at total supply chain, be it production, processing, or at transportation level or storage level. One third of the food is being wasted, which amounts to 1.3 billion tons and then 1 trillion of US dollars. And if we see the breakup, 45% are fruits and vegetables, which are very perishable commodity. Then 35% of the marine food, then cereals, dairy products, and meat and poultry. Out of which 8% is lost at the farm scale, 14% from farm to retail sector, and 17% from retail to food service providers, hotels, restaurants, meetings, and homes. And how much we waste at India?
Sorry for the interruption. You have lost 5 minutes to conclude.
Okay, so at India, we are consuming, losing around 1.3 billion. So imagine if we don't waste that food, we can save that much amount of emissions. We can produce less and waste less. Or if we produce more, then we can feed the population. This slide also shows about how we are losing and what percentage we are losing. Like of the total, if you talk about India, India is losing around 7.5% emissions due to wastage. Now, how do we reduce emissions from the food production system or agriculture sector? The thing clearly says that reduce the consumption of meat and dairy product, promote the low carbon production system, improve the crop yields, reduce wastage. So basically moving to sustainable diet systems, which can be able to reduce around 2 gigatons per year, not at least 6.7, then at least 2.2 gigatons. Now, how do we go for mitigation in agriculture sector? Mitigation, we have to be water efficient, we have to be fertilizer efficient, energy efficient, and pesticide efficient. So it offers a good opportunity for mitigation from the supply side and also from the demand side. Now, if you talk about plant management, we have to go for improved variety, crop rotation instead of monoculture, nutrient manager. We use efficient fertilizers and inhibitors so that we increase the nitrogen use efficiency. Go for different residue management, reduce tillage and residue retention. Go for different water management in case of rice, like improved water application system, for example, sprinkler or drip, and go for drainage so that we don't have methane emissions. Go for agroforestry and biochar application. Now, if we talk about methane, we all know it is from ruminants, rice fields, manure management, and residue burning. So instead of puddle transplanted continuously submerged rice, which requires more water, more labor, and more methane, we can go for aerobic rice, DSR, with drip fertigation, and SRI, which will reduce methane emissions. Nitrous oxide, when we talk about, sorry, it is from the land use, fertilizer application, manure management, and then tillage, and then crop residue burning. If we say different sources of nitrous oxide emission, fertilizer is the major culprit, contributing around 75 to 77%. Here I've listed one good paper which says how much a vegetarian and non-vegetarian consumes. So if we only 14% of the nitrogen produced by the herbivorous process enters human mouth. So from fertilizer production to nitrogen consumption is only 14%. Rest all is wasted. And if we see for the non-vegetarian, it is only 4%. So we have to reduce all these wastages as much as possible so that we save the losses. We conducted one study where we calculated the footprints of different food items. Here, vegetarian food is having lower global warming potential, and the non-vegetarian food like chicken and mutton are having very high emissions. Even the lacto-vegetarians are having very high emissions. So how do we go for a reduced emission? We go for right product, right rate, right time, right place, and right method. That is use. Here at present, we are having neem-coated urea, but we can have dual inhibitors so that we reduce not only nitrous oxide, but also ammonia emissions. Plant and soil test based fertilizer application rate using some sensors or leaf color chart. Instead of broadcasting, go for incorporation and foliar or placement method. These are some studies which suggest what are the different techniques which has the potential for mitigation and what are their impact on yield and what are the constraints. Similarly, one study was conducted where we
Please
estimated
conclude
what
in
are the
1 minute,
mitigation
madam.
potential. Just 2 minutes.
Take 1 more minute and conclude, please.
Yeah. So overall, we have this much potential to reduce for mitigation, but we have some challenges like increasing GHG emissions, slow adoption, lack of agreement, disjointed research, and inadequate. So what are the drivers? We require food and nutritional security, farmers' income sustainability. We have to have national as well as international policy, and we need technical, economical, and social requirement. Along with that, individual commitments. So this is all I wanted to tell about. I would end my talk that civilization as it is known today could not have evolved, nor it can survive without adequate food supply, but it has to be sustainable. This was given by Borlaug. Thank you very much.
Thank you, madam. Who is next? Sandipan Baksi and
Thank you, Chair. So, while I was listening to this, my previous speakers, I was thinking, what is that our presentation, alternative approaches towards sustainable agriculture and epistemological critique. Well, the title is still tentative. We are not sure if it is an epistemological critique, but let's for the time being, let's go on with it. So I was thinking, what is that is common in my presentation with other speakers? One, second, we are running late, so how do we manage that? So perhaps I'll try to do that. One. Let me start by thanking Sreeja, Dr. Sreeja, because Sreeja was talking about scenarios that do not account for global hunger till 2030, 2050, and even to 2100. And we will be talking about a system of production that has gaining in importance, that also does not account for food security, availability, and sovereignty, and the question of sovereignty that goes along. So it is a different kind of system of agricultural production, but that is something that sort of a parallel thread that runs across. The paper is, we have three of us, me along with my colleagues from FAS, Harshan and Dona, we have worked on it. Let's move on. Now this idea of, now, the idea of alternative agriculture has been gaining ground for some time now, particularly in the context of continued hunger despite of availability of food, one, and second, of course, is climate change. But the idea is not new. It goes back to early 20th century. There has been, these are some of the major these are some of the major schools of thought that have gone under the name of alternative agriculture. They became prominent at some point in time, lost prominence. Some of them again became very prominent. For example, regenerative, that has gained in prominence in the last 20 years. And of course, new ways, for example, agroecology have become very dominant in the alternative agriculture scene. Now, so it is clearly, it has, as everybody in this audience would know, it has been gaining importance. There are genuine questions that they have been raising, concerns that they raise. Some of them are very well-meaning, but they have often been critiqued of, sort of that their solutions that they offer are not aligned with science. And notwithstanding what they say, what we realize is that because it is gaining importance, it is important to critically engage with what they are saying and learn if there is something to learn from them, but also at the same time expose the limitations that they may have. And and there are very few systematic efforts in that direction, and this is one of, and that's where we come in, this paper comes in. So what we are doing here is actually, when we look at this whole discourse, the debates around various schools of thought, while these schools of thought vary in nuances, they're actually what organic agriculture claims and what, let's say, regenerative agriculture claim. When you go to the nuances, there are various differences, and this is not a attempt to go there. But there are certain claims which are really common, and two of such claims is what we have taken from. One, yields are not seen as central to sustainable agriculture. Second, local knowledge, local practices, indigenous, and so on, they are seen as central to sustainable agriculture. Now, in a previous paper, what we have done is tried to critique this externally, meaning we are trying to argue that no, yields are sustainable. Why yields are important? Why, and why so? Or why local and indigenous practices cannot take care of food security needs. But this is a slightly separate approach. Here what we wanted to look at, when these claims are being made, what is the basis of these claims? What is the kind of logical structure that is being advanced in the arguments that are being advanced? What are the evidences that are being offered to support these arguments? And what are the methods, the methodologies used, underlying methodologies that gives these schools of thought the sort of epistemological strength to say what they are claiming? Okay, so this just goes up and down. It's not very well managed. Anyways, we thought we would clarify our position. We think, and which is pretty much there on the board, we think yields have and will continue to play a central role. We also think that while there is merit in learning from local knowledge, but by itself it cannot be the basis of sustainable agriculture. This question, it is crucial to clarify that the position we have is informed by scientific realism, which means that while there are different systems of knowledge that can interact because there is the natural system that you are trying to understand has a materialist core, nevertheless, modern science is the most advanced, most evolved form of human knowledge, and therefore the standards of modern science are being used to assess the claims offered by these alternative systems of agriculture, approaches of agriculture. So what we did by way of methodology was, we first looked at these two claims that I was talking about yields and local knowledge. We started looking at them and reviewed various papers qualitatively to identify certain hypotheses in which these claims appear. So it is not that when it is said that yields are not central, it is not only in this form that this argument will appear in the various academic, in the scholarship. It will appear in various forms. So there were various forms in which they appear, and that was identified. And then using the keyword combinations that they use, we use this software called publish or perish, to find the some of the top cited literature from various journals using the Google Scholar database, each of them more than 100 citations. And from there we got the hypothesis and looked at each of these papers systematically to understand the logical structure, the method that they have used, and the evidences that they advance. Now here are the 4 hypotheses that we found under the first claim. First is crop yields. We will not be discussing all that in the interest of time. I'll limit myself to only 2 of these hypotheses, but at least we should highlight the 4 hypotheses that we came across. One, in various ways, this says that crop yields in history never experienced any revolutionary growth. It has always followed a trend. Second, very common, organic yields are comparable. It appears in various forms, but it is, in essence, this is the argument that is advanced. Third, alternative practices can improve yield significantly. Fourth, hunger is an issue just of distribution. It has not much to do with production. We have not, in this paper, we have not dealt with the 4th hypothesis. On the okay. So under this claim, we will just look at one of the hypotheses, that is H3. We can come back to other hypotheses if we have the time, which I don't think would be the case. Okay, thank you. So, see, the alternative practices improve yield. What are the different forms in which if you look at across these 10, 12 papers that are making these claims, which are highly cited, these are the 3-4 ways in which this will, and those who are attending these kind of conferences, they would also know that these are the ways in which this argument is put forward. Resource conserving agriculture increases yields. Agroecological systems may actually not just meet, they can outperform what is called conventional agriculture in these parlances. Food productivity increases irrespective of what is happening to crop yields, but food productivity will increase. And then there is another very common term that you would hear, in fact, even in many ICR presentations also, no yield penalty. What is the method that, if you look at the the various papers that are talking of these arguments, there are 3-4 major methods that we found are used across. One, participatory action research. So the thing is, it is always some 100 or 500 or maybe some villages. It's not only, I'm not here talking of the scale, but there is a systematic intervention that is being made, a methodological intervention, methodical, not methodological, methodical intervention that this systems or package of practices have to be followed. And then there is a group, either it's a group that may be a non-governmental organization or maybe some other research institution that goes and they ensure that these package of practices are followed in certain villages or certain areas in villages or certain households, and then the output is highlighted as the success of this alternative practices, okay? Whether the comparison is either in time or in across geography. So before we were using these kind of practices, this was the yield, now this is the yield. Before these households were using these practices, this is the yield. The neighboring households, there was no intervention, that see the yield. And this comparison is highlighted. The other method is project-based studies, which is very similar. Actually, these project-based studies, if you go into, you will find that they are mostly using this participatory action research. Third is specific case studies in one particular village, one particular household this has happened, or a group of household this has happened. And finally, these studies, which are maybe few, but then they are cited across to make the claim that is being made. Here is an example, and if you read the paper, I mean, we don't have the time, but this is the kind of thing for 360 reliable yield comparisons from 198 projects. So there were the 198 projects in different parts of a particular state, and they came up with 360, which are reliable yield comparisons, where these intervention happened vis-a-vis where the intervention didn't happen, and this was the basis of the claim. Now, and this is Pretty et al., it's a highly cited paper across, if you look at the alternative agriculture, Jules Pretty is a highly cited author. Next, please. So what we see first is, the most important thing that I want to, on this particular hypothesis is that the results that are being produced are sort of highlighted are results of intervention. It's a comparison of intervention vis-a-vis no intervention. If there are other plots, be it neighboring plots or the same plots before any intervention. In time you are comparing, or or across geography, the intervention is without any intervention, it's just in the farmer's field, things are happening as the farmer is doing it. There is a particular kind of result that is being achieved. When there is a systematic intervention, the results are of a different kind. Yields are found to be higher. This is very different from saying that this cannot be the basis of comparison of intervention of a particular type vis-a-vis intervention of another type. It's not that in the other field there is the extension system of a particular type is also being systematically sort of advanced as a package of practices. There is no intervention that is happening. So the comparison here allows us, I think, to conclude that this is the outcome of intervention. When you intervene systematically, even if the intervention in itself may be of limited nature, the yields tend to increase. Okay, if you have to, so that's my first critique of this point. Second, if you look around and you do the discourse analysis, while it is trying to defend these alternative agriculture practices, saying that this can improve yield, in reality, the argument being advanced is that this is a way of yield management, yield gap reduction, not improvement of yield. Okay, it is saying that if you do this kind of practices, if conservative agriculture practices are being sort of practiced, then yields can be managed, but this does not take away from the fact that yield improvement, it does not take away from the argument for yield improvement in itself, right? It is not antithetical to yield improvement. In fact, much of these studies also talk of this cooperation. They say that this shows that along with experiments to develop yield increasing varieties, yield expanding varieties, if these practices are also used, that can lead to much higher realization of yield. But they are used to make the claim that this is a better way to expand yield. So the actual thing is management of yield, but that is shown as an argument for yield increment. Third is generalizability. This is cuts across all these hypotheses that it is from few case studies, it is the mechanism through which it can be generalized is not discussed at all. It is assumed that that while saying that these local practices are grounded in local ecology, depends, it brings out the experience of a particular locale which is correct, but at the same breath, it is also assumed that such knowledge can be made general, general can be scaled up and scaled out. Finally, the extra resources that are required for these alternative practices are never accounted for. For example, push-pull or cover cropping. But if you go beyond one farmer's field, cover cropping may not always be such kind of leguminous crops that is edible. So that has to be accounted for. That has to be added in the denominator to see what is happening to the yield. But that is never tried. Okay, we'll take just one more hypothesis and conclude because I think we are running late. Okay, so anyone, let's take H5. Okay. So the form of argument here, again, this is interesting. The local knowledge captures experience. The different terms that you use, that you find in this literature they are context specific, holistic, ecologically grounded, unlike modern science, which is universalist, reductionist, power-driven, colonial. These are the kind of, and then there are certain degrees. There are those who talk of integration of these two sort of knowledge systems, and there are those who talk of replacement of it. So they will say that no, replacement of scientific knowledge by alternative or indigenous ways of doing things, and then there are those who will talk of how the both have to talk to each other and co-creation, synergies, these kind of language you hear. Okay, now in this case, we are getting the first warning only in 1 minute. I thought 5 minutes is when we'll get the warning. Okay, so we'll just take this. Thank you. So the method that they are using are all very rich. I must say that some of this is very rich anthropological description of the practices, techniques that are being locally practiced by the farming community of certain region. And then there are certain semi-structured interviews and case studies to understand what is the kind of local knowledge, what are the practices, what are the traditions that are there. So go on. I'll give you an example. So this example, if I know that this is long, these are two long quotations, but I will request your indulgence on the screen. The first is an example of the kind of studies that are done. 11 case studies were carried out under some research program, which you would recall I was talking about the participatory action research projects. This is the kind of projects that are done. This right side quotation, which I'll read out to you, is the kind of thick description that comes out. Okay, one is not related to other. These are two separate papers, but interesting excerpts. In southern Africa, spiritual rain-making ceremonies have been at the heart of many smallholder traditional societies. Ritual performers would conduct prayers, use medicine portions, brew and drink traditional beer, dance under trees among other activities in manipulating the falling of rain. These acts were known for yielding positive results to the autochthonous people. The biophysical views are deeply rooted on the premise of science to predict and manipulate both short-term and long-term climate. In other instances, they have the power to influence weather patterns through artificial practices like cloud seeding, among others. There is need for further research, especially in providing empirical evidence to support traditionalists and farmers' current claims of changes in seasonality and the role of spiritual ceremonies in reducing vulnerability. Do I need to say anything more? Please move on. So the point here is that excerpt, the point is not to make fun of that. It was an ethnographic description of a rain-making ceremony. The description, and it is anthropological in nature. You get to know what some people, some communities are doing. You can try to make sense of why they are doing so. Is it lack of knowledge or what is? what are the underlying, it can be the starting point of a further research. But that itself doesn't mean knowledge. If it has to be, if it has to be claimed that this is knowledge, and this is scientific knowledge, and it has to be kept at an equal pedestal, then it has this, we cannot just look at it as an experiential practice. Rather, the standards that are applied for any scientific, any knowledge to be called science has to be applied to that as well. There are these leaps of inferences. We see there is often there will be a talk of potential, and then it will be assumed that this will be actualized. So with these two, I will just go to the concluding. There are this similar exercise has been done for 7 hypotheses, and we will just look at some of the inferences that we could draw, which is common across these kind of hypotheses, which is the concluding slide that we will put up for you. Yeah, so these are some of the sort of larger inferences that one can draw if you do this systematically, one after the other claim. On methodology, these are tendencies that we could identify, which is what we are calling as epistemological. One is, on methodology, there is a tendency to do away with the need for concrete experimentation, be it modeling, statistical, any kind of experimentation to establish the validity of a hypothesis. The gap between a potential and its actualization is assumed, that there are concrete, very complex mechanisms that are required to realize a potential is never dealt with. Scaling up generalizability is assumed, as you as you would have seen. Then this is something that didn't come. Scientific consensus on a position. For example, yields increased during the Green Revolution in India. There is a scientific consensus. That doesn't mean you cannot challenge the consensus, but that requires extreme rigor. If there is an almost consensus on a scientific consensus on a position, to challenge that requires rigor of method that we do not see in this. Come down. Go up. Yeah. Then experiential or empirical observation, experiential is the word, is given a privilege over knowledge based on principles, laws, tendencies abstracted from such experience. The idea of an objective illusion, that you are experiencing something but it is illusory, is not regarded seriously. There is an a priori epistemic weightage to tradition. Mimicking nature is seen as important than learning from it and intervening it from those the learnings. Modern science is seen as an equal pedestal. Every knowledge is equal, and that modern science, with the scientific revolution and the industrial revolution that followed, there was an epistemic break that is not seen as given any regard. Go up. Yeah, go full. Yeah, that's it. There is a change in research focus. What is shown as yield enhancement is actually management of yield gap reduction somehow. No, that doesn't take away from the importance of enhancing yield. And finally, that the local community is also differentiated, that there are that power operates at that level is never given any serious importance. So these are some larger inferences that we try to draw from this study. Thank you.
I just wanted to add, I think, this very important work that Sreeja has done, and Sreeja and colleagues have done. I just wanted to provide a little more context because perhaps she assumed that the audience is fully aware of the context. My name is Jairaman from MSSRF, and I am responsible for the climate change theme of this conference. So the point is the following. If you want to know what is the impact of future warming, or what is the impact, the benefits you will get if warming is reduced, you have to make some projections, some assumptions about the future. You can, or you can say, it will be 2 degrees now, then it will go down. There are different ways of doing it. But one of the preferred ways is to have different scenarios of how emissions will be reduced in different parts of the world, in different economic sectors. The thing is, lot of this are what if projections, projections of what if. But what happens when the results come from the IPCC and the way it is projected by the IPCC leadership to the policy community is that this becomes what you must do. So you have various scenarios of emissions reduction, and we found to our shock and surprise that none of these in the IPCC actually take account of equity at the international scale, climate justice, or provision of basic necessities across the world, but privilege only emissions reduction. So as a result, it is quite shocking that the IPCC scenarios, none of them meet the goals of the SDG, as she pointed out. The population at risk of hunger increases, okay? And there is a number of such deleterious consequences, but none of this comes out in the IPCC report. So, and then they take these results from the IPCC, and they apply that as the yardstick of what countries must do. So this is very policy-wise deeply problematic. And so this work, I think, focused and parallel work which we have also done, focus attention on this issue at the global level. So it is quite an important contribution to the literature on this subject. Stop it.
Sandipan, wonderful study, quite revealing. You looked at biodynamic farming. I quickly browsed, of course, you had to go through the slides very quickly. Did you look at the zero budget natural farming also? You can be very general so that you don't make any.
Of investigation that we have used here is not looking at biodynamics or organic or alternative or any of these agroecology. We are not looking at it separately. We looked at that when we looked as part of our ongoing work, when we looked at these different schools, we found that there are certain common themes, although there are nuances that makes one different from the other. So two of these common claims we took up. One, yield is not central. Second, local, indigenous ways are better. And then we did this systematic search around these. So yes, zero budget natural farming also makes this claim.
The reason I want you to look at specifically at some of these interventions is because public money is being provided for promoting some of these issues. So we should make sure that it actually is not so much of romance, but it's actually real.
Yeah, I would like to add to this because since I worked in the ICR system, past 2 years this study has been taken up across different crops, like zero budget, then the natural farming and the chemical farming. All the three are being compared, and because within the internal, being inside the system, what we have understood that doesn't work equal to the chemical. But I think now the reports are yet to come, which has to be pleasing to the policymakers or the who are in the upper decision maker. But maybe we should be also watching the papers coming out. Because as you said, now you have looked into several papers reviewed, right? So I think over the years, now it has started, I think 2 years it has finished those experiments. At least 3 years they would take it, and maybe we will see the papers coming. The final report for sure, we can know what is going to be the answer.
The last question, please, because only one possible. He's raising, please give it. I'm sorry, Jairam, you are given. They don't have time, I will give it.
I just want to ask only if Dr. Niveta Jain is, she's not, okay, then it's fine. I just wanted to ask about the yield penalties associated with these alternative technologies. So,
Jairam, is it very pressing? Very pressing, you can give, otherwise we have to wind up.
I think the most shocking aspect of the cover-up of the unscientific nature of zero-budget natural farming is the complicity of the FAO, the complicity of IPBES, and the complicity of the Commission on Biodiversity's Global Biodiversity Outlook in creating separate box items in lead chapters, praising this as some move towards sustainability driven by indigenous knowledge. I think this is something has been passed over in silence in the international scientific community, and it is one of the most shocking things. I think it's a scandal on the proportions of what we saw in cold fusion, but at least cold fusion after 3 months was debunked, and this completely continues to circulate in public. And this is really, I think, something we ought to be shocked about.
So can you take a collective decision to sacrifice our time for the team? Because it's a very precious thing to have a discussion. Please feel free, and it's only for those who have not spoken, because the time constraint. You please, you introduce yourself to let you know.
I would like just to ask you whether you have come across any empirical studies in this regard, and whether you have subjected this kind of meta-review of research of those articles which have got empirical evidence. I think that also are coming up.
He said it's only reviews,
I know, I am talking about only the reviews.
Reviews are better real or not, that's what he said.
No, Sandipan, my request is, like this yield, give equal importance to factors involved in this production. The way the alternate agriculture practices they are promoting, the factors particularly labor requirements, other thing. As Professor Jairaman rightly mentioned, that even their latest paper in Nature or Science somewhere, this Vijay Kumar people, they published a paper, but they cleverly, moved away from these factors involved in this production. So we have to review that.
So I'll just, Dr. Jiju, I'll just take 1 minute. No, there are empirical works that happen, okay? And that most you would, ours is very limited. It's not a high meta-analysis. And when I'm saying when I'm critiquing generalizability, I don't want to, I am also subject to that critique. So I don't want to generalize. But if you look at the question of organic yields are comparable, there are many meta-analyses that are happening. Many. But even those who are sympathetic to the organic ways of doing, there are books, there are very critical studies that say that there is things to be learned from there. I am not an expert to look at the actual technology, what are its limitations. But if you look at even the sympathetic papers, they would say that under most of the, or they will specify under these conditions, or if there is a drought like situation, their organic would, in those years, organic may play out better, give better yields. Okay, so they will specify. But otherwise, except for one or two, Badgley is what one paper which sort of is cuts across this literature. Everybody would cite. But that is not the critical point. What we found is even the other paper, which is much more nuanced and balanced, in our opinion, says that, okay, in these conditions, it really worked. They would be cited to make the claim that that it has outperformed. It has outperformed conventional agriculture. So it's not the actual study, which of course may have a grain of truth, but how you cite it, that is where the epistemology, what I'm saying, epistemology operates. Okay.